Okay, so where we left off was question number 5. It said we had two charges, positive 6, negative, no, and negative 4 microcoulombs, and they were some distance d apart, and when they were, the force between them was negative 2 newtons. So Fq is equal to K Q1 Q2 over d squared, really, and this time you could solve for d. So d squared is equal to k q1 q2 over fq. So d squared is equal to 9 times 10 to the ninth Newton meter squared per coulomb squared, positive 6 microcoulombs, whoops, that's really negative times 10, negative 2 to the negative 6 microcoulombs, so make sure you type in negative 6 here, and then over negative 2 newtons. Don't forget to take the square root, and when you do, you get 0.2324 meters. So now the second part of the question says we're going to touch these two together, these two charges. And if you remember from Friday, we said when you touch two different charges together, they share the charge until they balance out. And so the way you find out what the new charge is on each of them is add them together and divide by 2. So 6 plus a negative 2 is 4 coulombs. Divide by 2, they each become 2 microcoulombs. And it says now the new R is 2D. So what'll the new force be? So you do Fq is equal to KQQ over R squared. 9 times 10 to the ninth Newton meter squared per coulomb squared. Both of the charges are 2 to the negative 6 coulombs. 2 to the negative 6 coulombs. And then the new R, 0.4648 meters. Remember to square it. And find your new FQ. And if you haven't rounded at all, I think you get 0.16 repeating newtons. Okay? So those are the 5 homework questions, which hopefully weren't not too bad. These last two might have messed you up just a little because of the way it was worded. If you would now find the sheet of notes that I gave you, because on the back of that sheet there are 3 examples. Example 1, if we had had more time in Friday's class, we would have done together, and it would have been just like the ones you did for your homework. So this one, it's just an object carrying a charge of negative 18 microcoulombs exerts a force on another object carrying a charge of 12 microcoulombs. And it says the force is a force of attraction. And so if it's a force of attraction, wants to know what's the nature of the second charge. If this guy is positive, and it only tells you the magnitude, it has to be a negative, because it wouldn't be a force of attraction otherwise. So the first answer is the nature of the second charge is a negative. Then it wants the distance they were apart. So it's just, again, Fq equals KQQ over R squared. But you're going to rearrange for, wow, is that my eyes, or is this really blurry? There we go. You're going to rearrange for R squared. So just like we did in the homework questions there a minute ago. So we probably do not have to go through this one. When you do it, though, just in case you try it on your own, you should get 1.5035 meters for R after you take the square root. 1.5035 meters. Okay, so if you didn't do your homework and you want to try that one, please do. The ones I want to look at today are example 2 and 3, because the reality is we don't always just have 2 charges that are near each other putting a force of attraction on each other. Sometimes we have 3 or 4 or 5, or if I'm really nasty, 8 or 9. So in question number 2, there are 3 charges in a row, positive 4, positive 5, and a positive 6 microcoulomb, and each are 0.2 meters from the next, and it wants the net force on the central charge. So draw a little line of charges, And this distance, it says, is 0.2 of a meter. And this distance is 0.2 of a meter. And if we call this one number 1, this one number 2, and this one number 3, so this will be the 4 microcoulombs, the 5 microcoulombs, and the 6 microcoulombs, okay? And so it wants to know the net force on number 2. Well, number 1 is going to be pushing number 2 away, right? Number 1 is there's going to be an FQ on number 2 from number 1 that's going to go that way because it doesn't like it. They're both positive. But number 3 is also going to be pushing number 2 away. So the force from number 3, FQ 3 2, or maybe I should have been consistent, 2 3, would be in the opposite direction. So the first step is to find what these two forces are. Then the second step is to do what we've always done, the sum of the forces. So first we're going to find the force that number 1 is putting on number 2. So 1 on 2. When I put my hand, okay, just a second, I'm trying to put my hand there, so there we go, 1 on 2. So FQ 2(1) will equal K Q1 Q2 over R squared. So FQ 2(1) equals 9 to the 9th Newton meters squared per coulomb squared, and then 4 to the negative 6 and 5 to the negative 6 divided by, and R was 0.2 of a meter, and you're going to square it. Okay, so type that in the calculator, and you can get the teacher to pause this at any point and rewind me. Anyway, but when you type that in the calculator, and I'd wait for you, but I'm on a 10-minute rule, you should get 4.5 newtons. Okay? It's positive, it means repulsion. You're going to do exactly the same thing for FQ 2-3. Doesn't matter if you call it 2-3 or 3-2. So you could pause the video right here, do this one on your own, and then turn me back on to make sure it matches, okay? So I'm not pausing, you pause. Alright, are we back now? So KQ2 Q3 over R squared. And so 2-3, 9 to the 9th Newton meters squared per coulomb squared. 2 is 5 to the negative 6. 3 is 6 to the negative 6 divided by 0.2 meters squared. And when you did this, you should have gotten 6.75 newtons, I think. Okay, so we have our two forces. So now you're going to do the sum of the forces, but when you do, you have to take into account their directions. So it's back here. So you have a 4.5 Newton force up here going one way, and you have a 6.75 Newton force going the opposite. So when you do the sum of the forces, it's going to have to be one minus the other. So Q21 minus Q32. Alright, and so when you do this, it'll be 4.5 newtons minus the 6.75 newtons, right? Because it's like this. So you need to subtract them. So you'll get an FQ on number 2 to be 2.25 newtons. And it works out to be negative. But what does the negative mean? The negative means it's going towards number 1. Okay, so an arrow and right here towards number 1. Okay? So that's example, make it small again. That's example number 2. It wasn't too bad because they were in a straight line. Example number 3, going to be a little tougher because it's not a straight line. It's in a triangle. Alright, so the triangle is a right angle triangle, like this. And it says there are 3 charges at the corner. It does say as shown. So let's put the 5 microcoulomb one up here, the negative 2 microcoulomb one down here, and the 3 microcoulomb one at this spot.